All right, let's take a look at this here. We're going to try to find points on a curve. In this case, the curve is an ellipse, as we can see here. And we're going to determine the points where you have a horizontal tangent here. So, like before, we need y prime to be 0 here. So that's what we're going to try to do here. Now, of course, you have implicit differentiation because what you're looking at is a relation again. And when you have a relation, it's going to fail that vertical line test. So you guys can see here. So it fails. And so we're going to have to use implicit differentiation. So we're going to differentiate with respect to x, the left side, 3x squared plus 4y squared plus 3xy. And then we're going to differentiate with respect to x, the right side. So again, on the left side, like we've seen, we're going to use properties of derivatives. So derivative of a sum is sum of derivatives. Derivative of a constant times a function is, pull out the constant. So, okay. Now what I'm going to do here is I'm going to differentiate the constant so we know that's 0. So this thing equals 0 here. So we have 3 times 2x plus 4 times this derivative, again, because this is a relation, y is not constant. Y is a function. So remember, we assume y is f of x. Now, what that really means is we're going to have to use chain rule. And by chain rule, this is 2y times y prime. Now, this derivative here, this next one, we're going to focus down here. And this is going to be product rule with, well, let's just say that now, product rule. Okay, so you can do product rule here. All right, so let me do some detail. So we're going to pull out the first part of the function. This is why I say product rule. We're going to pull out 3x. We're going to differentiate the second part, which is just dy dx. You can look at it this way, second function. So this will be plus, pull out your y. Now differentiate the 3x. So this derivative is just 3. So ladies and gentlemen, d dx 3xy becomes, if you pay close attention to this is my y prime. Three x y prime plus 3y. Okay, let's write this down together. This is going to be placed right here. We're going to add that and it'll be equal to 0. So let's take a look at everything all together. That's going to be 6x plus 8y y prime plus 3xy prime plus 3y. and then this will equal 0. So just double checking the work here. Okay, so now remember the second part of implicit differentiation is to solve for y prime here. Okay. Okay, so 8y prime plus 3xy prime, if we subtract 6x from both sides, subtract 3y from both sides, you end up with a negative 6x minus 3y. So as we solve for y prime, which is the second portion of implicit differentiation, we're going to factor out the y prime. And you end up with negative 6x minus 3y. So that y prime becomes negative 6x minus 3y over 8y plus 3x. I'm also going to go a step further. I'm going to factor out a negative 3 from the numerator, and that's going to leave me with 2x. Looks like plus y over 8y plus 3x. So let's double check this derivative here. Factor out that negative 6x minus 3y. There we go. Okay. There we are, ladies and gentlemen. So here's a derivative now. And so if you're going to talk about having a horizontal tangent again, find those locations where there's a horizontal tangent. Remember, I can kind of look at this and see maybe here somewhere you got that horizontal tangent line. And down here, you'll have a horizontal tangent line. Okay? And that's why we say we're going to set that derivative equal to 0 now. So y prime is 0, and we're going to have to solve for x. Just want to remind people, horizontal tangent. So algebraically speaking, you have negative 3, 2x plus y over our 8y plus 3x. This has to be 0. Now, I can put the negative sign at the same level. Okay. And what this means, again, let's remember to have that quotient equals 0. That means, if I try to find some colors, all right, let's use pink. That fraction equals 0, that quotient is 0. That implies your numerator is 0. So that means negative 3, 2x plus 2y is 0. Or if I put the negative, well, not negative 3, but we can say just 3 because that's the numerator. Or negative 3, it really doesn't matter. Because what this means is if I divide both sides by any number, it's not 0. This is why it doesn't matter. And that'll be 2x plus y. We got to be careful here. Very careful. Let's do the algebra correctly. 2x plus y is 0 here. So you might look at this, and this is my point when I said a while back before. This is kind of a rabbit hole to go down a little bit. Hopefully it's not a very rigorous rabbit hole, but I'm going to suggest, yeah, you have to find 2x plus y equals 0. Now, what that means is if your first derivative is 0, we know that this equation is true, which means if I subtract both sides by 2x here, you get y equals negative 2x. Now, this is what we're going to use, ladies and gentlemen, here. Okay, this is going to bring about some algebra, and this is kind of the rabbit hole I mentioned that I was looking to kind of avoid a little bit with some of these questions. But okay, it's not that big of a deal in this case, but it can be generally a very, very big deal. It's because you're not having a function of x equals a number that's solvable. You now have y equals negative 2x, and that's going to be a little bit more complicated. Now, we're going to use this relationship. Okay, so now stay tuned for the algebra, and this is what I mean by that. So I didn't intend for it to be this way, but okay. Anyway, here's what's going to happen, right? With the algebra, go back to the original equation, which is 3x squared plus 4y squared. I'm going to write that down. The ellipse is 3x squared plus 4y squared plus 3xy equals 24. There's your original equation. Let's double check. Yeah, okay. So what you're going to use now is this y is negative 2x, the y variable here. So wherever there's a y, you plug a negative 2x in. Negative 2x. Let me highlight that instead. So here's a y. Here's a y. You're going to plug in that negative 2x. All right. So what does our equation become in that case? Well, I'm going to keep it black and say here's 4 negative 2x squared plus 3x times the negative 2x will equal 24. So you end up with 3x squared. Now I'm going to do every detail because it sometimes is helpful. This is going to be a minus 6x squared equals 24. And you end up with 3x squared plus 16x squared minus 6x squared equals 24. So this is 19x squared minus 6. So 19 minus 6 looks like it's 13x squared equals 24. And now x squared is going to be 24 over 13 here. Now, this is an equation that we solve out. This is more algebra, right? So we're going to use the square root formula. So what that means is x will be plus or minus square root of 24 over 13 now. So let's double check. What is this here? Now, by properties, I should say, of radicals. I'm going to just label the algebra I used here. So we're going to use square root formula. Now, really, this needs to be simplified. Okay? So I'm going to go through all the devil in the details kind of thing. It's going to be the square root of, to simplify this radical, I would do that in intermediate algebra. The square root of 24 over the square root of 13, which will be the square root of 4 times 6 over the square root of 13, which is 2 square root of 6 over the square root of 13. If you rationalize here, the denominator, which is what you want to do, you're going to end up now with that x being plus or minus 2 square root of 6 times square root of 13. That's going to be the product rule over there. So that's going to be 6 times 13 is 18. Looks like it's square root of 78. Is that right? Let's see. Yeah. Over simply the square root of 13 times the square root of 13, which is 13. Now, these are the two values of x. This is what you're looking for. So we have x equals positive 2 square root of 78 over 13. That's one answer. X being negative 2 square root of 78 over 13 being the other answer. Now, these are the values of x. So you might say, okay, Mr. Judge, that was some work. No big deal, but it was some work, right? How do we get the y value now? Well, remember when we went with this assumption that horizontal tangents occur when that first derivative is 0, which means y is negative 2x. Now, in theory, you'd have to go back and plug in these x values into the relation here and get your y values now. But if I say, y is negative 2x here, we know that to be true for horizontal tangents with this ellipse. This is what we're going to use to get the y values. Y is negative 2x. So we're going to use that. Oh, since y is negative 2x, we're going to be able to get this location here, hopefully. All right, so what does that mean? Well, when x here is, I'm going to try to keep this with colors. Hopefully you guys can see it. When x is positive, y is negative 2 times 2 square root of 78 over 13. So y will be negative 4 square root of 78 over 13. Similarly, since y is negative 2 times x, what happens when this x is the negative? Well, it's going to give you positive, right? So y is going to be 4 now. Square root of 78 over 13. So if you're talking about points again, do we have any? We need x and y, right? So my first solution is when x is a positive 2 square root of 78 over 13. 2 square root of 78 over 13. The y value, here's a corresponding y value now. It's negative 4. Very similar. Negative 4 square root of 78 over 13. Now, similarly, when x is negative 2 square root of 78 over 13, we found over here. This is your y value. 4 square root of 78 over 13. Anyway, I can write a 4. So here are the points. This is what they're looking for. Now let's double check here. Okay, so, just kind of remind people here of what we just did. And you're going to end up now with these 2 points. This is the answer. Now, if I said, let's take a look at Desmos, I have to really try to remember these numbers, which is going to be hard. And I'm going to go here and remove that. So let's go to the curve. I guess I'm going to have to write it down here. We're going to have to do it again here. I don't know where that curve is, but let's go back to what that curve is, the name of that curve. All right, I think I have it. Let me get it here quickly. Three x squared, okay? So it'll be, thought it was 3x squared. 3x squared plus 4y squared plus 3xy equals 24 now. Okay, so we're going to look at, see what we have. Let's change that color. Okay. All right. Now we're going to look at some points here. So I'm going to put here, if I can, put the first point if you guys remember what that first point is. All right, see if you guys can see. There is the ellipse. So let's go back and see 2 square root of 78 over 13. 2 square root of 78 over 13. So 2 square root 78, come out of there, divided by 13. The next location was negative 4 square root of 78, come out of there, divided by 13 here. So I'm going to label that location. So as you guys can see in this picture, it is a point on the curve. That's the location. So I'm going to do something further. If you guys remember, y minus y1, that's going to give us a horizontal tangent of y, we should say, equals negative 4 square root 78 divided by 13 here. So there's a horizontal line there. Let's make that red so you guys can see it. So they didn't ask for, by the way, the line, but as you guys can see, this is the equation of the line tangent to the curve at the location of that particular point there. And that line is horizontal. It's touching the curve. Okay, we're on the right track. And so the other line, x is negative 2 square root 78, come out of there, divided by 13, comma, positive 4 square root 78, come out of there, divided by 13. Let's label that point. And again, that point is over here on the curve, as you guys can see. And we're going to write that equation of the line. And that's going to be y equals positive 4 square root 78, come out of there, divided by that 13 now. Okay, now let's change that color to red as well. So that's kind of the idea. So ladies and gentlemen, yeah, you can actually see exactly that definitely these are the answers and we're on the right track here. Okay, so let's bring that in, okay? I'm going to bring that in this demonstration for you. Bring that in. So here's the locations, and I think it's going to go all the way at the bottom. Okay. And so, ladies and gentlemen, there you go. These are the X and Y coordinates. These are the locations they're asking for. These are the points. And I hope you guys enjoyed this demonstration. But as you know, back in here, the key will be that when you let y prime be 0 here, you actually end up with a line. Y is actually negative 2x here. And there's going to be some algebra here now because of it. So you always solve this particular question here. This is kind of the key. And so whatever algebra you get at that point, you know, is it could be involved or it can be okay to do. This was not too bad, but, you know, it was a rabbit hole to go down. And, of course, we used essentially intermediate algebra now to get through this. And we do get the two locations, as you guys can see here. Okay? So I hope you guys enjoy the demonstration of this question. And have a good evening.